Hi, everybody. In this video, I'm going to walk you through how to use this particular interface to go through the different requirements of the protein structure project. Now, one of the things you'll notice in the protein structure project after I post the more detailed requirements is that you have to walk through the different structures. Now, you've already done a little bit about the primary sequence or primary structure as shown up here. And if you don't remember, each one of these letters represents one amino acid. So primary structure is just the linear sequence of amino acids. And so this is a cysteine, this is a threonine, this is a threonine, this is a phenylalanine. And if you're having a hard time understanding that or figuring out how am I getting which amino acid this is, down in the lower right, I can't move my cursor or else it won't show this anymore. But down over here is where you can actually get the specific information. This is aspartic acid 10. This is aspartic acid 11, amino acid number 11. This is amino acid number 12. It's a valine if you look in the lower right. Okay, that's the primary structure of one of these polypeptides. Now, right now, I actually want to skip to the fourth level structure, the quaternary structure, which you can see by the color coding. So the colors show you each polypeptide, and there are three of them. Now, one of the things I want you to realize is that by switching the way we're viewing this protein, it's easier to see different types of structure. Now, this type of viewing is called cartoon, and it shows secondary structures extremely well. Hopefully, you can see that if we zoom in here, this is an alpha helix, and this is a set of beta sheets. All right, here's another beta sheet shown by these arrows that are in parallel with each other or anti-parallel to each other, and then we have a bunch of helices vertically here. So the cartoon model is very good at seeing secondary structures. If you want to get an overall shape of the whole tertiary and quaternary structure, I would suggest you switch the view. And there are different ways of doing so. So if you go to the right-hand side, under Components, if we click Components, if you go to Polymer, Cartoon is not necessarily what you want in all cases. The three dots opens up the different selections. And instead of adding a representation, I'm actually going to go down to where it says we're in cartoon representation. And I'm going to switch that. If I click on that, I can change which one I want. And in this case, I'm going to go to a Gaussian surface. This gives you an overall shape of the whole thing. Click Update. And now it's a little more clear that it's three polypeptides wrapped around each other. What's also really useful about this view is you can see where the interactions are happening between the different polypeptides. So if I was looking for a particular binding site, that is, between these, and I want to know, wait, why are these two polypeptides holding on to each other? What kind of an interaction is happening here? Well, I could actually look at this amino acid. This is an arginine, and this right here is an asparagine. And I could postulate what kind of an interaction might be happening between those amino acids, right? So again, the amino acid is identified in the lower right, and it's actually highlighted up here as well. And so you can actually see which amino acid is each little spot here. Okay, so just to take a step back, if we were looking at quaternary structure, we count the number of the polypeptides. We look at the overall orientation, we can see that this is symmetric. There are three polypeptides in threefold symmetry. And in fact, the name of the file shows that C3 symmetry, which is not something you have to understand. I'm just letting you know that this is a symmetric molecule. And you can see that each one of these three is identical. And while that might not be visually identifiable, it's identifiable here in that A, B, and C, all three chains, have the exact same primary structure. You can see that the amino acid sequence hasn't changed between those. Okay, so that gets us to the fact that we covered primary structure, quaternary structure as well. And if we go back from Gaussian surface to cartoon, we can get a view of secondary structures. Now, the last requirement in this project is going to be to highlight the actual specific examples of bonds that you can find in here. So I would like you to find a hydrogen bond that is part of secondary structure. I'd like you to find, say, a hydrogen bond or an ionic bond or a disulfide bond in tertiary or quaternary structure. So I'm looking for examples of each. All right, so I want you to really look at examples of each. So if you're wondering, how do I find those things? Well, there's a few different ways of doing so. One of the representations you can choose is actually non-covalent interactions. And what this will primarily show you is hydrogen bonds. And so as soon as this finishes updating, which takes a while, all it's showing now are the hydrogen bonds. All it's showing are the hydrogen bonds. And what I might want to do in addition is add another representation on top of this. So maybe I'll add on a ball and stick model. See if this works. All right, so I could do that. And this will show you the ball and stick model as well as the hydrogen bonds. I don't actually think that's a good choice. I kind of screwed that up. So I'm going to get rid of the ball and stick representation by trashing it. And I'm going to add maybe the cartoon instead. If I zoom in, if you see these little gray or white dotted lines, every single one of those is a hydrogen bond. So let's look at the secondary structures. Here's an alpha helix. That alpha helix is held together by backbone hydrogen bonds, and that's right here. If I highlight this, if you look in the lower right, you'll see that this is an isoleucine, ILE, and a valine held together by a hydrogen bond in the backbone. I want you to know isoleucine and valine are both, they have non-polar R groups. They would not form a hydrogen bond between the R groups, and they don't form hydrogen bonds between the R groups. What we're seeing here is a hydrogen bond between the